This is a production of World Video Bible School. To God be the glory.
The next argument we're going to look at concerning the existence of God is called the teleological argument. Teleological argument. Now, that's kind of a big word, but the easier way to remember that is design demands a designer. Now, in the books, here's the way it would be described. The natural processes show a preordained purpose and interdependent design evidencing an intelligent designer. That is the way that you'd read about that in the book. But let me help you remember. Design demands a designer. If you were to find a watch lying out in the rocks somewhere and you picked it up and it had the exact correct time in it, you wouldn't say probably, well, I wonder how that happened. You'd say, oh, a watch, and you'd just automatically know that someone designed it. It can tell time. It has been accurately made to do so. And we know, therefore, that design demands a designer. And certainly that's one of the big arguments, one of the easiest arguments to make with someone concerning the existence of God, because we see design in the universe, we see design in the human body, and we see design in nature. And we're going to look at all three of those in this presentation. But not everybody accepts the same idea about the teleological design making an argument for God. For example, 92.5% of the leading physicists and astronomers in the National Academy of Science reject the idea of a personal God altogether. Now, they may think there's something big guy in the sky kind of thing, but they have no idea that there's really a personal God. Maybe he's an electronic force out there somewhere, but not a personal God. And let me also just get you to thinking back in the right direction here a minute. What if a computer that was made and designed by intelligent human beings, what if that computer someday would be able to actually think? And in its thinking, it came to an independent conclusion that it originated purely by natural means. What would you think of a computer that did that? Well, that's kind of like human beings. Here all of a sudden we have gotten smart enough that we say, well, we didn't really have to be made. We just made ourselves. And the evolutionists try to get us to believe that. And so what we want to do is to look at the teleological design and see whether or not, first of all, that it is what the Bible teaches, and secondly, is what science harmonizes in teaching with the Bible. In Psalm 19, verse 1, it says, "The heavens declare the glory of God, and the firmament is declaring the work of his hands." Well, the question is that true? Is it really true that when you look up into the sky and you see the sun, the moon, the stars, and the galaxies that are out there, do they really declare the work of God's hands? Well, let's just go beyond just the passage of Scripture here. A man by the name of Cicero, many of you are familiar with him and his writings. Back in 43 BC, he was neither a Jew nor a Christian. 43 BC, he was a Roman orator. He said, "The celestial order of things and the beauty of the universe compel me to admit that there is some excellent and eternal being who deserves the respect and homage of man." In other words, Cicero said, when I look up into the sky and I see the stars and I see everything that's going on up there, he says, I can't do that. And I know that there must be someone who is eternal, who is intelligent, who is excellent, and I believe that he deserves my respect. If a pagan can come to that conclusion, surely men of science can do that today. But let's look at some other things concerning this to see whether or not there's really evidence of that. In a book by Robert Clark called The Universe, Plan or Accident, on page 90, he makes a comparison of the Earth with other planets. Now listen to these 9 points that he makes here. Number 1, situated at the right distance from the sun. Next, built to the right size. Next, its radioactivity active elements concentrated in its crust. Next, uniquely provided with a satellite large enough to brighten the night and control the rhythm of nature, rotating in such a way as to produce day and night and seasonal variations in temperature, largely covered with water which keeps the temperature more constant still, provided with continents and ocean basins and with water to fill them, provided with an atmosphere of the right kind, and with an ocean containing salt which enables clouds and rain to form, but to preserve life has never developed strong alkalinity or acidity. What more can we ask? Now you really have to think about that, because those things are just a few of the major circumstances that are characteristic of our earth. And we must have those things in order for life to exist. Now we could talk about each one of those, but really what we're trying to do in this survey of Christian evidences is to mainly just expose you to some of the things that are so important in making the design argument. Let's look at just 7 probabilities of planet Earth. Being in the right place in the galaxy, scientists have estimated that 1 chance in 150 would be being in the right place in the galaxy. Number 2, having the right kind of star would be 1 chance in 1,000. Being the right distance from the sun would be 1 chance in 10. Having the proper mass, 1 chance in 10. Having the proper spin, 1 chance in 10. And by the way, not all the planets spin the same way the Earth does. One of the planets spins backwards, another planet is turned on its edge, if you will, and it spins around this way as though it's north to south. And so we have exactly the right spin. And then having the right tilt is 1 chance in 10. And then having a magnetic field that is capable of shielding us from things coming into the earth that are harmful, 1 chance in 10. Now, what do you do with statistics? 2 or 3 of our presentations in this series will be using some statistics. So let me introduce you to the idea. In order to find out what are the odds, what are the chances of all 7 of these things occurring in one planet, you multiply each one of those times the other. Now I'm going to save you some math here. The answer would be 1 chance in 15 billion. 1 chance in 15 billion. Now you think, well, you know, it could have happened. 1 chance in 15 billion, we could have that. Well, let me show you what the kinds of odds are. The Parachute Club statistics tell us that if you fall out of an airplane at 10,000 feet without a parachute, your chances of survival are 1 chance in 10 million. Now, if I were to offer you $1 to jump out of an airplane without a parachute at 10,000 feet, and you knew your odds of survival were only 1 chance in 10 million, how many of you would do that? I would suppose that not many of you would. But what if the odds of having the right planet with all these other things exactly all on one planet would be 1 chance in 1,500 times greater than that? Why would people bet their soul on saying, well, it just happened? Because you see, that doesn't really make very good sense. As a matter of fact, I have some other statistics that deal with this. Let me just show you a couple of them. There have been some scientists who've gotten together and they have said, let's assume that there is the possibility of 10 to the 19th power planets. That would be 1 with 19 zeros after it. Let's pretend that there are that many planets. Certainly no scientist knows that there are that many planets. As a matter of fact, scientists don't even know that there are more planets than we have in our solar system. There are some theories about them and some suggestions about them. But let's play like there are 1 or 10 to the 19th power planets. Do you know what the chance of finding one planet that was hospitable to life would be in that circumstance, according to these scientists, it would be 1 chance in 10 to the 414th power. Now, earlier, we were looking at a very small number, but can you imagine one with 414 zeros after it, what that number is? Well, let me give you another number. There is a man whose name some of you will recognize, and I'll tell you in a minute who it is. But when he was writing his book, and I'll give you the name of the book, he said the chance of life evolving on Earth is 1 chance in 10 to the 2 billionth power. Now, that would be 1 with 2 billion zeros after it. Now, what's amazing to me is there are people in the world that accuse Christians of being silly for having faith. But if you believe that the chance of having one planet that is hospitable for life to be on it, like Earth is 1 chance with 2 billion zeros after it, that's a bigger faith than I think most Christians would even have. But let me show you who said that. Carl Sagan. Carl Sagan was an astrophysicist. He was a person who had a show called Cosmos on public television, and he was against Christianity. He was against the Bible. He was against all the good things that we're familiar with, and he was the one who said that in his book, Communications with Extraterrestrial Intelligence. And by the way, that's printed by the MIT Press, page 46. And so the idea is people know that having an Earth like ours with all the right things on it for life is very unusual, very unusual. And yet we have it, don't we? I wonder why we have that kind of planet with life on it. It almost seems like it was designed. And what did we say? Design demands a designer. Well, there have been a lot of studies that have been done along this line. As a matter of fact, back in the 1930s, some men got together and they were discovering something about our planet, and it was that this planet has everything that is exactly right for life, but not just our planet. Even space is exactly right for life on our planet. And they call this the anthropic principle. Now, some of you are familiar with the word anthropos. That's the word for man. And so it's basically the principle that allows man to exist or to live. And it's called the anthropic principle. Well, the work was done on that for the next 30 or 40 years. And in 1985, a man by the name of Paul Davies wrote a book called The Accidental Universe. Now, Davies tells us that there are there are more, but there are 4 special things that must be exactly right from the beginning of matter. From the beginning of matter. Please catch that phrase. In order for us to have life on this earth. And let me briefly go over those things with you. Now, this is a little bit technical, and we're trying not to be very technical in most of these presentations, but just listen to these things and notice how accurate or how exact it must be for us to have life on the earth. The first one is the condition of space. Actually, the present temperature of space requires that the expansion of the universe, the expansion rate of the universe, be fine-tuned in different directions to 1 part followed by 40 zeros. And it had to be at the birth of the universe. It could not have evolved into being that way. It had to just, boom, be that way instantly. 1 chance followed by 40 zeros. I don't even know the name of that number, but just write down a 1 with 40 zeros if you're taking notes. That is part of the anthropic principle. And the idea is the cosmos, the entire cosmos, has too many precise parameters that are critical to the survival of life to be the product of chance. That's what the anthropic principle is all about. Let's look at number 2. The nuclear force between protons and neutrons. Now we're looking at an atom here with proton and neutrons. If that nuclear force between those, and we're not talking about a nuclear force that well, of course atoms do blow up, but we're not talking about that kind of power. We're talking about just between the proton and the neutron. If that nuclear force were weaker, carbon and iron would disintegrate, and therefore you'd be having no life. You see, you are a carbon-based life form. If you've seen television shows, you've already been told that a number of times. However, if that little bitty nuclear force between a proton and a neutron were stronger, all hydrogen would have been consumed long ago. No hydrogen, no water. No water, no life. Therefore, it had to be that way from the very beginning of the cosmos. Number 3, the gravitational force. If it were any stronger than it is, all matter would be drawn together into a massive black hole. Stars would burn up quickly, the universe would collapse, and the stability of an atom would be an impossibility. And of course, therefore, no life. On the other hand, if the gravitational force were weaker than it is, the reverse of all these events would occur, and again, no life. Do you know what that exact force is? It is 6 to the 67th times 10 to the minus 11th power. Exactly. Folks, that means it had to be exactly right at the beginning of the cosmos. This could not be something that evolved over a long period of time. It had to be right to begin with. Now let's look at the 4th and last one of these, of the technical thing. The electrical force between particles. Particles smaller than atoms. Particles. The electrical force between particles in nature is 9 times 10 to the 9th power. 9 times 1 with 9 zeros after it. A slight change in electric charges would cause the atom to be unable to do any kind of chemical reaction, and the stability of the atom itself would be impossible. And you see, without all of these, all 4 of these, and there really are more, but all 4 of these, DNA could not exist long enough to allow life to survive on this planet. And they had to all be there exactly as they are from the very beginning of time. So do we see that it really is true what we read back there in Psalm 19? The heavens declare the glory of God, and the firmament is showing the work of his hands. We actually do see that. But let's move to another area. Now that we've looked at the universe or the cosmos, let's kind of narrow that down. Another biblical claim is found in Psalm 139, verse 14. It says, I am fearfully and wonderfully made, and that my soul knows quite well. Well, we have to ask the same question. Is that really true? I mean, yeah, the Bible says it, but is it really true? I mean, do scientists know that these things are really that true about the human body, that we're wonderfully made? Well, McAllister, in his book, Man Physiologically Considered, now that's a book on the study of the human body, said this: the unprejudiced mind, and notice the way he words it, the unprejudiced mind cannot fail to read in every organ, nay, in every cell and fiber, the inscription of purpose, and to learn that they are the products of some supreme power directed by supreme wisdom. Now, the man who wrote the book is professor of anatomy at Cambridge University. He has a Master of Arts degree, he has a medical doctor's degree, and he is a fellow of the Royal Society. This is a man who does know what he's talking about because he has studied the human body. Well, let's just start with a few examples, and then we'll try to use a number of them as we go through to talk about how wonderfully made the human body really is. I've got an article about the brain, It is amazing. It was written by a medical doctor, and it's a long article, so I'm not going to read the whole thing, but his name is R.J. White. He's a medical doctor, as I said. He also has a PhD. He's also a neurosurgeon, and he is the co-chairman of neurosurgery at Case Western Reserve at Case Western Reserve University Medical School in Cleveland, Ohio. He is also the director of neurosurgery at the Cleveland Metropolitan General Hospital. So the man is qualified. He knows about the human brain. And he says, there has to be, in summary, I'm going to just summarize the whole article, but he says there has to be a superior mind that thought up the human mind. You see, what he's saying is design demands a designer. He believes that the human mind has been designed to be able to accomplish what it accomplishes. Well, let's look at that. Let's look at the scientific end of this thing. Neurons, your brain is made up of neurons or nerve cells. There are 10 billion nerve cells in your brain. The first 9 months of your life, you are making 25,000 of those every minute. Now, besides the nerve cells or the neurons, you also have dendrites and axons. And those are little bitty connecting fibers that are each in contact with 10,000 other fibers. Can you imagine that? Now, 10,000 of these, each connecting with others. As a matter of fact, you have a total of 10 to the 14th power of these. That would be a 1 with 14 zeros after it. If we could take them out of your head and lay them end to end, and of course obviously they're extremely small, but with 10 to the 14th power of them, actually putting them end to end would make a line 100,000 miles long, 4 times around the center of the earth. Can you imagine all that up in your brain? You see, this is why we talk about design demands a designer. Now let me tell you how much power your brain has. On a typed page, a page like this perhaps, you can type approximately 300 words. Well, on a 3.5-inch CD, you can put 40 to 200 million words. And the Library of Congress has 20 million volumes in it. That equals about 2 trillion words. But your brain has the ability to hold 2.5 trillion words. Now I realize you're saying, hey, if I'm so smart, how come I can't remember my neighbor's name? Well, recall is another problem. But that's how much power there is built into your brain. How much did you have to do with that? Not very much, did you? You see, the idea is it couldn't just happen. And the reason is because that's design. And design demands a designer. Now, fortunately, a few years ago, I was in Hawaii and an unusual thing happened to me. I was standing up close to the top of a volcano and it began to erupt. So as I started running down the volcano hill, the hill that the volcano was, unusual stuff started happening. The lava that started coming out of the volcano began to melt all the rocks that it was touching. And out of those rocks, metal started coming out. I mean, just popping out all over. And not only the metal, but as it went on down, there were some rubber tree plants there, and it started melting the rubber off those rubber tree plants. And it was amazing to me how the rubber was just popping out there all over the lava. And when it got down close to the sand on the seashore, it started popping this sand, and the sand started piling up, and it started making glass. And you know what happened because of that volcano? Well, look, this is exactly what occurred. This car occurred. Can you believe that? I mean, look at the body. It was shaped perfectly for an automobile, but it just kind of was the steel as it rolled down the hill that did that. And then those tires, the rubber tree plant, just wrapped itself around the metal and made steel belted radials. I thought that was really neat. And the shock absorbers and the fan belt and the alternator in there. And what's really amazing is as it came down, the glass just popped up into the area where if a guy was in there driving, he would be able to look out the front and see where he was going. And the steering wheel happened to be connected to the wheels. Well, I was absolutely amazed. Now, how many of you believe that? Yeah, well, I really wasn't even in Hawaii, let alone see all of that happen. But you know what? If that is the way that we were to explain a car, people would call us, well, probably mentally challenged. And that would be a very nice word for it. But you know, when we began to look at the human body, I want to show you some of the things that it has that is even far more amazing than what's in a car. Now, we don't believe that that car just happened. Well, did man just happen? Or must we really conclude that a supreme intelligence designed man? Let me remind you again of Psalm 139, verse 14. I will praise thee, for I am fearfully and wonderfully made. Marvelous are thy works, and that my soul knoweth right well. As we see on the chart here, we have a self-restoring, self-repairing healing system. Well, now when you fall down, you skin your finger, what grows back there? Well, obviously skin does. Did you decide that, or did it just happen? And then you have a sensitive, stereophonic, auditory system. Matter of fact, the stereo places are making money because you like to have your ears tuned into every single thing that you can possibly hear with those. What did you decide on that? Or what did you come equipped with that? Or what about your tireless muscular connecting tissue system? Now, when I say tireless, I don't mean you don't get tired. What I mean is that you can work all day, you can go home and rest, and you can work all day the next day. You can do that for 30 or 40 or 50 or 60 or 70 years. And did you decide that you were going to have a muscular connecting tissue system that could do that? And then what about your rugged yet sophisticated digestive system? Now, in all reality, we're going to come back to 4 or 5 of these again. This is going to be one of them. But basically, let's just think about the fact that you can eat everything from mashed potatoes to Mexican food, and your stomach says, okay, I can deal with that. And then what about your analytical, sensitive taste smell system? Now, as most of us know, everything that we eat really is only for taste, and everything else is smell. We like the smell of bacon. We like the smell of a particular kind of food that's our favorite one. But it really may not even taste. We can just basically taste salt and sour and bitter and sweet. Besides that, everything else is smell. That's why sometimes food does not taste as good, we say, when we have a bad cold, because we really can't smell it so well. And then we have a well-engineered skeletal framework. We may be talking about that in another lesson, but there have been a lot of evolutionists who say we were never intended to walk upright. Well, that isn't correct. As a matter of fact, we now have found out the cause of so much back problem is because of diet and the way we use our backs. As a matter of fact, to say that would have to mean that no animal who still walks on 4s would ever have any back trouble. And they do. Think about the little long dogs that have back trouble, and horses that have back trouble, and other animals that have back trouble. So just saying that we were never intended to have walk on 2 legs is certainly not a scientific statement. And then we also have a fantastic, extensive blood circulatory system. And I will come back to that one again as well. And then we have that computerized memory bank brain that we talked about a while ago, where you have the equivalent of you have the ability to have the equivalent of 2.5 trillion words in your brain. You also have an ultra-sensitive nerve network. Isn't it nice how all the nerves in your whole body work together to tell you things that you're feeling, things that are hurting, things that are you're touching or whatever. And then you have a programmed glandular hormone system. And what a fantastic thing it is. You're able to do all kinds of things because your body releases certain hormones at certain times to perform a certain function. And again, you didn't come up with any of these yourself. You see, it couldn't just happen. And then let's look at the next one. You have a filtered, warmed respiratory system. Where I live in Denver, we have snow from time to time, and sometime people get out and start shoveling that snow, and a few of them have a heart attack. Matter of fact, recently that has occurred in our town. However, scientists and doctors have also discovered that some of the people who die while they're out shoveling snow did not die of a heart attack, even though it seemed like it. What happened was that they began to breathe through their mouths when they got tired. And instead of letting the cold air get warmed by going through their nose and down into their lungs, they took it directly into their bronchial tubes. They froze, they could not breathe. And of course that would cause chest pains just like a heart attack would, but they died. And a few have even had that circumstance happen to them. We need to do it the way it was planned. Also, we have a ventilation, insulation, skin envelope. The skin is the largest organ of the body. And certainly, can you imagine people without a skin? It not only helps us look a little better, but it also protects us from all the things that our body would be exposed to if we did not have skin. And then we have a fantastic waste, recycle, and disposal systems. We also have an unfathomable reproductive system. One of the hardest things for an evolutionist to explain is the human reproduction system. And then we have voice and language mechanisms. We'll talk about that later on in the evolution section, but we do have a unique quality that we can communicate with each other. In addition, we have an elaborate danger warning system. We have that flight or fight ability that happens to us automatically when we're scared. We have that adrenaline just pumped throughout our body that helps us to be able to run or to fight. And one of the things that I always like to say is the reason that fat people are friendly is because they can't run or fight. But let's go back to the chart. The last thing that we have is a living lens, living color, optical system. Now, considering all these things that we've just talked about, could they really just get there by chance? Or are they really something that argue for design? And remember, when we're talking about design, we always are saying design demands a designer. Now, I told you we were going to come back to some of these and look a little bit more in detail. And I'd like to especially note for you about your whole DNA. You are made up of DNA. But your human DNA has more organization, information, than the entire encyclopedia has. All of you have seen Encyclopedia Britannica or Americana or one of the others. Can you imagine how much information is in those books? Your one person's DNA has more information than that, all the time telling your body exactly what to do from the time of conception till the time of death and even afterwards. And so how in the world could that possibly be just something that happened by pure, blind, staggering chance? On the eye, even I have a quote here from a man from the Science and Evidence for Design in the Universe, New York City, by the Wethersfield Institute. And he said a panel of philosophers and scientists argued that it is time to restate the cause for intelligent design because the eye makes it harder to claim that mechanisms like the eye could have happened by chance. Darwin's famous assertion that the human eye had evolved at random from a light-sensitive spot seemed a simple thing to Darwin. But modern biology shows that a chemical process needed simply to register a photon is extremely complex. Remove one step from the creation of the eye, and the whole thing will not work. Interestingly, recently in the National Geographic, they tried to show people just how the eye evolved. That does not work. Theirs is far too simplistic to explain how an eye could have evolved by chance, and therefore it certainly doesn't stand well for the National Geographic to try to have used that as proof of evolution. Well, let's look at some other areas. The human ear. Only the human ear has 3 semicircular canal structures which allow us to walk fully upright for extended periods of time. And primates and all so-called pre-humans that the evolutionists are trying to find the link for, have only 2. That's no support for evolution whatsoever. Let's look at the tongue. Look at all the things the tongue does. It'll warn you when your food is too hot. Have you ever noticed, though, it's about a ½ second late? Anyway, it warns you when food is too hot. It'll manipulate your food into a little ball so you can swallow it. It has about 9,000 taste buds, and it also secretes a peptide that acts as an antibiotic. Have you ever seen a little kid when he gets his finger hurt? What's the first thing he does? Right into the mouth. Where did he learn that? Where did you learn that when you did it? You see, the idea is there's something in there that can kill germs. Isn't that amazing? We have our own germ-killing factory right there. And then what about our saliva itself? We produce more than 1 quart a day of saliva into the mouth from just 3 different glands. And of course, it moistens food and it lubricates it, making it easier to go down. And it also has ptyalin and amylase, which begins to convert things into sugar, especially the starches into sugar. And its lysozyme is a bactericide or germ killer. And so it really does do some things about killing germs and getting your food down to the place that it's going to be digested. So let's talk about that place. Let's talk about the stomach for a minute. Your stomach holds about 1½ quarts. And there are gastric juices that come into that stomach from 3 different glands. What is amazing about the stomach is that it will digest food at 98.6 degrees, which, if there was no such thing as stomach, it would take 212 degrees, that's boiling, in strong acids to do the same thing that your stomach does at 98.6 degrees. But another amazing thing about the stomach is it's meat, it's flesh, but it doesn't digest itself. Now, why does your stomach, which digests all that meat that you eat, not digest itself? Well, one of the reasons is because it's lined with the mucus, and that helps a little bit. And the mucus is alkaline, which neutralizes some of the acid that's in there. And then when you put food and liquid in there, it dilutes the acid a little bit. And then another thing that happens is your stomach cells are shedding at a rate of 500,000 per minute. And your stomach replaces those 500,000 every minute in your stomach. And then we get a new lining of our stomach, therefore, about every 3 days. Isn't that amazing? Well, your stomach has hydrochloric acid in it. Why doesn't the hydrochloric acid just eat right through and just eat through everything? I mean, if you put a nail in hydrochloric acid, it'll dissolve that nail. What happens in your stomach? Well, there is something that's so totally unique in the stomach that there's no way that evolution could explain how this occurred. Because you see, if it didn't occur first, as soon as that hydrochloric acid got in there, you would have killed yourself with just that acid. So you had to have the cells that line your stomach the most unique in your entire body. One side of that cell is totally impervious to everything. It doesn't allow anything to go through at all. It doesn't allow carbon dioxide to pass through or anything else. The other side of that cell is normal, which allows the oxygen to come in and the carbon dioxide to go out. This side is on the side of the stomach, inside of the stomach. This is on the other side of the stomach. Now, how did that happen? Why is that the only cell, the cells in our stomach? Why is that the only place that happens? Because that's the place where the hydrochloric acid is, which is needed to digest our food at 98.6 degrees. Isn't that amazing? You see, it's almost as if that were designed. And design demands a designer. And you see, this does not happen in any other cell. Well, let's go now from the stomach to the liver. The liver performs 500 different functions. 500 different functions. Every year, your liver filters the equivalent of 23 milk trucks of blood. You know those big, shiny milk trucks? Can you imagine your little liver filtering all of that every single year? 23 trucks of those. And in addition to that, it stores the vitamins that you need. It detoxifies the poisons that come through it. It stabilizes the body's blood sugar level. And it manufactures enzymes and 496 other things. Did you make it do that? How did it just happen to do all those things? In coordination with all the rest of the function of the body. Well, let's move from the liver to the heart and the circulatory system. In 1 hour, your heart, beating at a regular amount, generates enough strength. If you could put it all together, the strength that your heart does would be able to lift a medium-sized car 3 feet into the air. It beats about 100,000 times a day. That's about 40 million times a year. And it pumps 1,800 gallons of blood a day. That's 600,000 metric tons in a lifetime. This is all happening in your body. And every 0.8 of a second, your little sinus node produces an electrical current that tells the heart, time to beat. Have you ever thought about why it does? It's told to do so by that little sinus node. And it pumps blood from all parts of the body to all parts of the body. Through the lungs, it's reoxygenated, sent back out to every part of the body. And it keeps the body blood regulated at a proper temperature by a thermostat that's in your head. As the blood goes through that thermostat, it knows what to do, whether to constrict the vessels so the blood will go slower and warmer, or to open them up so it'll go faster and bring them up to the surface so it can be a little cooler. Did you decide to do that? Or was there design in your body? As a matter of fact, even an evolutionist says the cardiovascular system integrates information as well as any computer and then responds as no computer can. Don't we normally think computers are designed by higher intelligence? Why is it that the heart would not have to be, and the entire circulatory system? Another evolutionist, Miller and Good, in their book say, for a pump that is keeping 2 separate circulatory systems going in perfect synchronization, it's hard to imagine a better job of engineering. Don't we normally think of engineers as intelligent people who can design things that work? Why would we not think that there was a designer of the body? So the Blue Cross and Blue Shield of Connecticut came out with kind of a humorous thing. It says, if you're tired at the end of each day, it's no wonder. Your body is a busy machine. Your heart travels 103,000 beats 103,689 times. Your blood travels 168,000 miles through your body. You breathe 23,040 times. You eat 3.5 pounds of food. You drink 2.9 pounds of liquid. You perspire 1.43 pints. You speak 4,800 words. And you exercise 7 million brain cells. No wonder you're tired at the end of the day. But do you know what? Even with all this information, and we have merely touched the hem of the garment, even with all this information, atheists still object. They say, well, in all this design and everything, there's a lot of useless design. For example, they use the dandelion. They say a dandelion will produce more seeds than actually end up rooting. Now, not in my yard, they don't. They all root, I think. But the dandelion does produce a lot of seeds that do not turn into root. But you know what? There's an answer to that. And I like to read this one. This is from Mr. Gersner's book called Reasons for Faith. Listen to what he says. So much of the world seems to be non-purposive. There seems to be so much chance. The dandelion seed has a parachute that is eminently adapted for the purpose of transportation. Still, many of these seeds land where they cannot germinate. What about them? Now see, the atheist really thinks he has you here. Let me explain what the answer to that is. Factors which are not obviously purposive do not militate against those which obviously are. Now this is still in his book, and I'm quoting. As long as it is clear that the dandelion seed that does take root in the earth was adapted to that end, we have evidence of purpose in the universe. 1,000,000 instances to the contrary cannot offset this recurring fact. There is evidence of purpose even in those seeds that do not take root. Now listen to this, his comparison. If a man were trying to catch a wild animal that was molesting his neighborhood, it would be considered a mark of intelligence for him to set a number of traps and not just one. Now, true, only one of those traps would actually be used to catch the wild animal. But to ensure the accomplishment of his purpose, he would be wise to set many. And that's exactly what God has done. In order to make sure that dandelions and all other things like that, even though some of those seeds don't ever really produce dandelions, he was wise to make sure there were enough that would. And you see, we call that design. And design demands an intelligent designer. Now, let's look at one other area. Certainly, we've seen that the cosmos is designed perfectly for life to be here. We've looked at the body and we've seen that it is designed exactly the way it needs to be and just demands a designer. But let's look at nature. Now, in the Bible, there are some passages where God is speaking to Job in chapter 12, and God says, "But now ask the beasts, and let them teach you, and the birds of the heavens, and let them tell you. Or speak to the earth, and let it teach you, and let the fish of the sea declare to you. Who among all these does not know that the hand of the Lord has done this? In whose hand is the life of every living thing, and the breath of all mankind." What I'd like for us to do now is to just look at some things in nature, how wonderfully they're made, and notice that these things in nature demand a designer. Let's look first at a beaver. Now, everybody knows that beavers build dams. And did you know that a beaver will build his dam entrance so that he can get in based on how deep the ice is? And you say, well, that's not too hard. You know, he figures out, here's how deep the ice is. I'll just go down below that and make my little entrance. Well, what you may not know is he builds his dam in the summer based on how deep the ice is going to be next winter. How does he do that? How is a little creature like a beaver able to tell weather better than our weathermen do in their meteorological degrees that they have? Well, let's look at another one. What about whales? Whales have a baby, and a mother whale, when she's having a baby, makes a whistling sound that the other whales can hear under the water, and another female comes, cuts the umbilical cord for the baby, and then that midwife whale, we can call her, stays with her till the baby is secure. As a matter of fact, stays with her about 2 weeks until the baby is able to get around on its own. Where did they learn to do that? As a matter of fact, the very first baby whale that was born, now, of course, you got to go a long way in evolution to get whales, but let's just assume for a minute that that first baby whale that was born, nobody came and cut the umbilical cord. Nobody stayed with the baby until it was able to handle things for itself. How can we still have whales? You see, it couldn't just happen. Let's look at another one. Wombats. Now, in America, we're not very familiar with wombats. They're mainly down in Australia, and they're a marsupial animal, which means they have their baby, but the baby doesn't come out fully mature. It has to go into a pouch and grow into maturity. And so a kangaroo pouch, of course, faces up because a kangaroo lives above the ground, and the baby can climb up from where it's born, climb up its mother's pouch, get in, and hook on. There's two little nipples in there that produce milk. If it hooks onto the wrong one, it'll die. But if it hooks onto the right one, it lives. And so a little baby, which is, by the way, only 3/4 of an inch long, kangaroo will be able to do that. And he grows up into become what we normally call a joey, a little baby kangaroo. And we see a mom hopping along out there. Well, there's a problem with a wombat. They dig holes under the ground. Now, if their pouch was turned up like a kangaroo's pouch and they're digging a hole under the ground all the time, guess what's going to happen to the baby wombat? It's going to have all that dirt stuffed in on top of it, and it's going to die. Now, evolutionists tell us that over 1 million years, that pouch slowly turned around the other direction. Well, what happened to all the early wombats? How come we still have wombats? You see, evolution just cannot explain these kinds of things. Have you ever noticed birds perching at night or in a tree at any time? But you notice at trees at night, some of the birds are staying up there and they're, I guess, what we would call asleep, and yet they don't fall out of the trees. Well, why? Well, because when a bird lands on a limb, its leg, the tendons in the leg, cause the toes to automatically curl around that limb when he perches. And even if he's asleep, he won't fall out of the tree. Then in the morning, when he gets ready to leave, he lifts his weight up off that, his leg releases, the tendons relax, and he flies off to do whatever he's going to do the rest of the day. Isn't that amazing? Think how many birds fell out of trees before that evolved, and all those cats down at the bottom of the trees had supper every day. Well, that really didn't happen. You see, it couldn't just happen. But what about bats? They don't perch in trees. And they've got another problem. They've got to hang on to something. And bats have exactly the opposite design. When they go to latch on to a cave roof or to a limb, as you see here in the pictures, with the tendon, when it pulls down on that, their weight pulls down on the tendons, it automatically locks onto the cave roof or to the limb, and it stays there all night until it gets ready to fly away and releases that and flies off and do what bats normally do, which I think is mainly scare people. But the idea is it was designed to do exactly what it's supposed to do. Now, this next one I don't want you to look at too early. I want to talk to you about what happened to oysters. There were some scientists who decided that they would go get some oysters off the coast of Connecticut. Now, oysters eat when the tide comes in. They just open their shell, and of course the tide brings the food into them. Well, they close the shell after the tide goes out, and they've had their meal. Well, these scientists thought, you know what, I'll bet you they know when the tide comes in to do that. So they took these oysters from Connecticut, in the ocean, in the Atlantic Ocean, and they moved them to Illinois. Now, if you're not from the United States, you may not know that Illinois is not close to an ocean. But within 2 weeks, these oysters began to open their shells at the time a tide would come in if there were tides in Illinois. Now, how could they possibly know? you know, I don't know how big an oyster brain is, but it isn't really equal to yours or mine. How does it know when the tide comes in? Well, we have a picture that shows that. Many of you did not know that oysters had a little arm like that with a watch on it, and they looked to see, well, never mind. You know that really isn't what happened. But you see, design would explain that, wouldn't it? An oyster can live in any ocean, in any sea, anywhere in the world, and it'll still be able to eat. Isn't that amazing? Well, let's look at another one. Termites and fungus. I hope that you're not about to eat right now, because we're going to be talking about African termites and some fungus, which actually turns out to be their friend. Now, most of you know that termites eat wood, or actually we call it cellulose. But termites have a problem. These termites cannot digest cellulose. Now, that would mean they could eat it until they popped, but they couldn't digest it, so they would die. But guess what there is that lives in this same area in Africa? There is a fungus that digests cellulose. Well, these African termites go out and they gather this fungus. And this fungus digests the cellulose for them, and they can live. But now there's a problem here. This fungus cannot reproduce in the darkness. And what they do is they bring it into these anthills like you're seeing here on the screen. And the fungus, if it stayed there forever and ever, could never reproduce. So once they died, that would be the end of the fungus, and that would be the end of the termites. But there's a rainy season in Africa. And every rainy season, the termites clean all the fungus out of their anthill, and they take it out into the wet, rainy season, and that's where the fungus reproduces. When the rainy season is over, the termites go back out there and get the fungus and bring it back in and allow it to digest the cellulose for them. So the real question, I guess, is which came first, the termites or the fungus? Well, we know that that's what's called a symbiotic relationship. The termites cannot live without the fungus doing what they do, and the fungus cannot reproduce without the termites doing what they do. Which one came first? Looks to me like they came at the same time, and isn't that wonderful? Evolutionists wouldn't say that fungus and termites evolved at the same time, but design does, and design demands a designer. One of the most beautiful butterflies we know of is the monarch butterfly. And one of the unique things about this butterfly is it doesn't just hang around home all the time. It has a migration route. As a matter of fact, the first generation, they live basically down in Mexico. The first generation will fly up to Texas and Louisiana, and then they'll lay their eggs and they'll die. Now, as you know, a butterfly does not come directly from those eggs. A caterpillar comes from those eggs. And then after the caterpillar has lived a certain length of time, it'll make a cocoon, and it actually turns to jelly. I mean, if you were to break open a caterpillar cocoon that is turning into a butterfly, at first it'll just become jelly. And then that jelly in just a few days turns into another beautiful monarch butterfly. Well, that second generation of butterflies will go on up to the Great Lakes, and then they will lay their eggs and die. And another caterpillar is produced, and that caterpillar will turn into a butterfly, and that butterfly then is the third generation, and he will go from the Great Lakes to the Appalachians and the East Coast, and she'll lay her eggs and die. I think I've been saying he, and again turns into a caterpillar, and the caterpillar will turn back into another monarch butterfly, which will be the fourth generation. And that one will fly from the East Coast to the Gulf Coast and back down into Mexico, where its great-granddaddy started out. Now, how do they know? How do they know? This is not the same one that went up there and turned around and came back. It is the fourth generation that did that. And remember, the butterfly didn't become another butterfly immediately. It first became that caterpillar, which then became the butterfly. You see, this looks a whole lot like design, doesn't it? And we know that design is a part of what a designer does. But there's even something maybe even more unique about butterflies, especially the monarch butterfly. It has to do with their legs. What you're looking at now on the left-hand side is the legs of a male butterfly, a monarch butterfly. And when it's magnified 100 times, it looks like the one on the right. Actually, about the only purpose of these little legs, and most of the time when you look at a butterfly, you don't even see these. These are up at the front, and they're very, very small, but the male legs are primarily used just for balance during mating. Now, look at the female leg, and you'll notice on the left-hand side, there are 6 little points there. Sometimes when I'm making this presentation, I'll pick somebody's name out and I'll say, and for so-and-so, those are little pointy things. And well, that's exactly what they are. They're little pointy things. And on the right-hand side, those little pointy things, those 6 pointy things, are magnified 1,000 times. Now let me tell you what she uses these for. When a female monarch butterfly lands on a prospective plant that she may be thinking about laying her egg on, she will stick those little pointy things into that plant. And you see all those little devices over there on the right? The nutrients are absorbed by those. And the female butterfly can tell whether or not there is adequate nutrition in that plant for the caterpillar that's going to come from the egg she lays on there to survive. If that plant does not have enough nutrition for the caterpillar to survive, she will not lay the egg on that plant. She'll go to another one and stick those little pointy things in it and keep doing that until she finds one that it will. How did that happen? By evolution? You see, it couldn't just happen by chance. Well, there's even more. I think that butterflies are very, very beautiful, but probably one of the most unique little things that flies around is a hummingbird. And a hummingbird is the only bird that can fly any direction it wants to. Well, it's the smallest bird. Some of them weigh no more than a dime. But it also has an unbelievably high metabolism. As a matter of fact, its metabolism is 50 times faster than yours. I've been trying to figure out how to make a little pill out of that for a diet pill, but that's another story. But you know, it must consume food all the time of its waking hours, or otherwise it'll start eating itself up. It'll start starving. But at night, it doesn't eat. So how does it survive? Its metabolism drops to 1/15 that of its daytime metabolism rate, and its body temperature drops to that of the surrounding air. If you were to ever find a hummingbird at night and picked it up, it would feel as if it were dead because the blood is moving so slowly through the body that it feels like it's congealed. But it isn't. Well, I mean, it could be dead, but it normally isn't. And the next morning when the sun comes up and it gets ready to fly off, that metabolism comes right back up to what it was, and it goes around and eats all the rest of the day. How did that little hummingbird ever figure that out, to drop its metabolism rate at night and then come back up the next day? You see, that's design, and design demands a designer. Well, what about the polar bear? If I were to ask you what color is a polar bear hair, many of you would say, well, a polar bear hair is white, just like the picture you're looking at. Well, I'm sorry, a polar bear hair is not white. A polar bear hair reflects white, but a polar bear hair is clear. It acts as a thermal diode. Actually, the bear hair will absorb ultraviolet rays. The sun does not even have to be out. it'll absorb the ultraviolet rays, and it will actually put the heat from the ultraviolet ray into the skin of the polar bear. And isn't that neat that he lives up where it's cold? What if he lived down at the Amazon area and he would just die of heat, wouldn't he? But you see, this is the idea of design. Other bears do not have that characteristic. Their hairs do not send heat into their skin, but a polar bear's hair does. And where does a polar bear live? And how in the world did he ever figure out to make his hair different from other bears' hairs? You see, it's design, and design demands a designer. You know, one of the most unique things that happens is that which a wasp does. There is a particular kind of wasp down in Costa Rica, and it will go over and find a spider. It doesn't make any difference what kind of spider it is, but it will go to that spider and it will sting it, and it will lay its egg on the abdomen of that spider. And then it will fly away. Well, that spider in just a little while recovers from that sting, and it goes back to doing what spiders normally do, spinning spider webs and catching little insects and so on, eating them. However, in a few days, something very strange happens. That spider starts doing something it has never done all the rest of its life. It starts spinning a web that is stronger than it's ever done and in a shape that it's never done it in. And then in a little while, that spider will die, and the egg that has been laid on its abdomen starts becoming the new wasp that, just like its mother was. But that spider web is used to make a cocoon out of. And while that little future that future wasp is in there, it finally develops into a real wasp, which during the time that it's there eats the juice out of and the rest of the things out of the spider while it's in that cocoon. And then the spider drops off, the cocoon opens up, and the wasp flies out to do it all over again. How did evolution ever occur to cause something like that to happen? Can you explain it any other way than by design? And then there's another one, and that has to do with the woodpecker. Now, the woodpecker is really a unique bird. It has, most birds have 3 toes on the front and 1 on the back, but a woodpecker does not. It has 2 toes on the front and 2 toes on the back of its foot. And that's so that it can walk up and down or sideways or any way that it wants to on a tree. Plus, the tail feathers of a woodpecker are spongy. They're stronger. They're stronger than other birds' tails are. And they're made out of very tough material that helps give him the balance that he needs to do what he's going to do. Now, you know that a woodpecker uses his beak to chop into a tree or other wood things, and his beak is separated from his head by a little cartilage. As a matter of fact, it absorbs the shock, and it does not cause that little woodpecker to have a headache. If you ever imagine him going home at night and telling his wife, "Man, I've got a headache like you won't believe. I've been hitting trees all day long with my head." Well, no, doesn't happen that way. As a matter of fact, its skull has the thickest bone per body weight of any creature there is. Scientists are studying the skull of a woodpecker to see just how it is created and how it's made, or how it's, in their mind, how it's made. But let me tell you about the tongue of a woodpecker. Now, when the woodpecker does peck in that little hole and makes it so that he can go in and find the insects that are in a tree, it has a 10-inch tongue, 10 inches long. Now, most birds' tongues only come out to the end of their beak, but not a woodpecker's. As a matter of fact, on the end of the woodpecker's tongue, it has little barbs that are there. And it can actually, when it sticks that tongue in that hole, it can go down in the tree and stick it into a little insect that's in there. Or if he can't get that barb to find an insect, actually it has sort of a glue. It has a sticky substance on it. And an insect will stick to that tongue. And he pulls it back out, puts it in its mouth, and guess what? The glue dissolves as soon as it goes into his mouth. Otherwise, he'd be swallowing his tongue all the time. But you know, every time that woodpecker pecks on that tree, that he closes his eyes in between. Now, all of you have heard a woodpecker probably, and it's a very rapid fire thing. And you wonder, how in the world does he close his eyes and then hit, close his eyes and hit, and close his eyes and hit, and do that over, you know, how many ever times a second he does that? And that works out really well. You know why he does that? Because if he didn't, his eyeballs would pop out. Have you ever seen a blind woodpecker? Well, of course not. It works every time. How did he ever figure that out, that he needs to close his eyes? Because every time he hits the tree, he hits it so hard, his eyes would pop out. And there is another woodpecker called the European green woodpecker. His tongue, like all tongues, start in the back of the throat, but instead of coming out like the regular tongue does, it comes out a place in the back of his neck. It goes under the skin. It goes up over the top of his head, under the skin, and it comes out a little hole between his eyes, and then it goes into his nostril in a little hole that's there for his nostril, and then it comes out his beak. Now, the question you have to ask is, why in the world did that happen? Well, nobody really knows. But I'll tell you what, evolution surely couldn't explain that, because you see, that's designed. And by the way, it works perfectly well. It gets those bugs out of trees just like all the other woodpecker tongues do. And design demands a designer. Now, one of the things that we'd like to talk about is what we call mommy's milk. Because you see, moms have a unique ability. Every time that moms have a baby, of course, they're most able to produce milk for that baby. And did you know that the mom's body knows whether that was a full-term baby or a premature baby? If it was a premature baby, the kind of milk that is produced by the mom's body is different than the milk that would be produced if it were a full-term baby. In addition to that, did you know that when a baby nurses, if it has an infection, now this is an infection that the mom has not been able to find. There's no sign of it yet. But when the baby's body has an infection and he nurses, the next time the baby comes to nurse, there will be an antibody in that milk that most of the time will kill the infection in that body of the baby. How did you moms do that? You're really good. That's fantastic. We're so glad you did that. But when did you decide to do that? When did you evolve that quality? What happened to all the babies that died because you didn't have that quality? You see, it's design, and design demands a designer. Probably one of the most unique creatures in the world is a little creature called the bombardier beetle. Now, this is a book about, it's for children. It's called Bombi, the bombardier beetle. And I'd like for you parents and your grandparents to think about getting one of these for your kids. It's really fun. It's a storybook, but it tells a lot of information about the bombardier beetle. Now, the bombardier beetle is just a small beetle, but it has a fantastic defense system. On one side of its body, it has a gland that makes hydroquinones. On the other side of its body, it has a gland that makes hydrogen peroxide. And when it is scared, when it's attacked, it'll squeeze those two glands, and they go into a little chamber at the back of his body that's called a firing chamber, and it'll mix with a catalyst. And when it comes out of that catalyst, it comes out at 212 degrees. That's boiling. And it's not just a stream. It's really something that sort of is like a machine gun firing out those kind of things. And notice in the picture here how the little beetle can twist his body, the back end of his body around to ward off people who are attacking him in the front or things that are attacking him in the front, or he can stick it straight out and do that to things that are attacking him in the back. Now, you may notice that a scientist has a forceps attacking his front leg there. That's why he's got that thorax twisted around there and shooting that around there. Now, how in the world did this little beetle, whose brain is nothing like yours or mine, how did this beetle decide to have the right kind of stuff on one land and the right kind of stuff in another land and the right kind of catalyst here? What if he got that all mixed up and blew up? Well, there'd be no more bombardier beetles. But you know what? Design is the answer. And when there's design, there must be a designer. One of my favorite characters, and one that I'm sure I don't even need to tell you about, is Rheobatrachus. Oh, you say you've not heard of Rheobatrachus? Well, that's a little frog, and he doesn't live really in the United States. He lives in another country mainly. But he has a unique characteristic. When the mama frog lays her eggs, the daddy frog comes along and fertilizes those eggs. And as soon as he does that, the mama frog swallows them. Now, most of the time when something like that happens, that means they make a good lunch, but they don't come out babies. But that isn't what happens to the Rheobatrachus mommy. You know what happens to her? As soon as those eggs hit her stomach, even if she had food in her stomach, that food, the digestive circumstance stops. And then it stays dormant all the time those eggs are in there. And then after a while, those eggs begin to growing into little baby frogs like you see there in the picture in the mouth of that Rheobatrachus. And what you are finding out is that those frogs get bigger. And when they get bigger on the inside of the mommy, it actually causes her lungs to collapse. And you might think, well, if they collapse, that's the end of Rheobatrachus. Nope, not so. As a matter of fact, she begins to breathe through her skin. And then when the little babies are ready to come out on their own, like they are shown here in the picture, you can see they're very, very small. That's a paper clip that's up there for comparison of their size. They come out and they do what little baby Rheobatrachus frogs do. They just go around and live happily ever after. Well, at least they're eaten by something else or some other thing happens to them. But you see, how did that ever happen? When that first Rheobatrachus ate those eggs, how did her stomach know to stop digesting them? And when those babies started getting bigger and her lungs collapsed, how did she know to start breathing through her skin? And how was her body fixed to do so? You see, this is design. And if there's design, there must be a designer. What we've looked at in this one lesson is design in the universe. We've looked at design in the human body, and we've looked at design in nature. And what we've seen in every single case is that design demands a designer. And so as we conclude this study, let's look at what we've done here. There is abundant and obvious purposeful design. And this is the opposite of chance. It is the result of thought and plan. Purposeful design is also the mark of intelligence. When we see a computer, when we see a 100-story building, we say somebody must have been really smart to build that. We know that design that's done on purpose is a mark of intelligence. So, for the conclusion of this lesson, we can say, along with the conclusion of the previous one, it is logical, and that's what we do in Christian evidences, to find out which is more logical. It's logical to believe there is an intelligent being who can plan and work things together into an orderly universe. And He is the powerful, non-physical cause of the universe. Since intelligence denotes personality, this God that is intelligent and non-physical is a personality God, a person God, just like the Bible tells us He is. Yes, there is purposeful design in the universe, and design demands a designer.